All right. So, the last lesson that we're doing to finish off this portion of the unit is derivatives of quotients. Okay? So, we're now going to look at how to take the derivative of the quotient of two functions. D by dx equals f at x over g at x. So, technically, you already have a strategy to take the derivative of a quotient. And if you completely show what you know, you had to do it 3 different times, where you have to bring the denominator up as a package, raise it to the -1 or the negative exponent, and then apply the product rule. Okay? So let's use that strategy to differentiate f at x equals 3x squared minus 5 all over x plus 4. So we're going to use the strategy, not a new strategy, we're just going to use the old strategy to prove to you that you can still use this strategy. So you start by doing a rewrite. So as soon as I bring x plus 4 up as a package, you guys I have to start packaging everything to make sure I keep track of what goes together. So the numerator, 3x squared minus 5, gets packaged in a set of brackets. And then the x plus 4, what do I need to remember to do? X plus 4 to the -1. So I've rewritten this as a product. Everyone okay with that? Okay. Because I've rewritten as a product, I'm allowed to use product rule. Derivative of the first. Derivative of 3x squared minus 5. 6x. Times the second. I copy the second, everything. Plus the first. I copy the first. Lag time on my smartboard today. What's happening? Okay. 3x squared minus 5. I've got to trust it's going to show up. Okay. Times derivative of the second. The second is x plus 4 to the -1. Uh-oh, red flag. What do I have to recognize is happening? Chain rule. Law to the -1, right? We have an outer function and an inner function. So you remember, I suggest that your strategy should be you open a square bracket, because the first thing that's coming down is the exponent. And what exponent's coming down? -1. You can write 1 or just the negative. I copy the inside, blah. What's the new exponent? This is where people mess up the most. They forget about this exponent. To the -2 times derivative of inside. Derivative of inside here is kind of boring, but still write it. 1. There it is. There's my product rule. So I have 6x times x plus 4 to the -1. I want to rewrite this so I don't have like the negative just randomly in the middle. So what would be my in front sign or in front value? It would just be negative, and if there had been a number there, the number would go there, but it's just a 1, so it just basically switches the plus to minus. 3x squared minus 5 times x plus 4 to the -2. Okay, do you think that you're done this question on the test? No. Because the goal is to get this to be a single expression. Right now, it's 2 separate expressions. And the best strategy is, if you remember, you treat these as 2 separate packages, and you try and factor out the GCF. In this case, for the GCF, I look at the 6x and 3x squared minus 5. Is there anything, there's nothing happening that's in common there, right guys? Don't start looking. It has to be identical to remove. Nothing there is identical, can't do it. But x plus 4 to the -1, x plus 4 to the -2, is there a piece there that's in common? The x plus 4 base. And if you remember, what would be the exponent you take out? The lowest. And I know it's weird, but what's lower, -1 or -2? -2. So I go x plus 4 to the -2, which leaves me with, the 6x did not come out, so I need to rewrite that. When you take out x plus 4 to the negative 2 and you had x plus 4 to the negative 1, what's going to be left over in this spot? Remember, when you're factoring out, you're dividing. You just divided x plus 4 to the negative 1 by x plus 4 to the negative 2. According to exponent rules, what does that leave you with? You have x plus 4 to the negative 1, and you divide it by x plus 4 to the negative 2. You keep the same base and do what to the exponents? Subtract. What's negative 1 minus negative 2? 1. If you do this correctly, there should be no more negative exponents anymore. Okay? Okay, I'm going to erase what I just did there just because I need the space. But that's what I just did in my head. Okay? Over on the right, after the minus sign, the 3x squared plus 5 I'm going to keep it as a package, but the x plus 4 to the negative 2 already got removed. So now it's all about cleaning up what's in the square brackets. And where am I allowed to put the x plus 4 all to the negative 2? I can just make that the denominator. So we're going to have x plus 4 to the 2, and then I'm just cleaning up my numerator. Distribute 6x to x plus 4, 6x squared plus 24x. Be careful here, don't do all the hard work and make a silly mistake here. Minus 3x squared plus 5. 6x squared, oh no, lies. What's 6x squared minus 3x squared is just 3x squared plus 24x plus 5 all over x plus 4 all squared. Okay. Now, perfect, that would be final answer. You could double check to see if the numerator is factorable. Okay. I don't think this one is. Sum to 24 multiplied to 15 for decomp. I don't see it. Okay. I just want to highlight something here just in case. If you wanted to, and it's your comfort level, if you are not comfortable with this strategy, although I highly recommend you try and get comfortable with that strategy of factoring out the GCF, you could have, okay, just to show you an alternative, you don't have to do this, don't write this unless you want to write it once you see how it works. You could have, as soon as you get to the step, rewrite both with positive exponents and then just get it to have a common denominator. Does that make sense what I just said? So I could take the first expression there and go 6x over x plus 4 minus 3x squared minus 5 all over x plus 4 all squared. But I don't leave it like this. I need a common denominator. What would be the common denominator, guys? X plus 4. So in order to make that happen, what would I have to do to the 6x? Multiply it by, and then this is where you got to be super careful when you do this. The minus, this is a package. I want you to take a look at the numerator here and look what's in the brackets there. Do you notice something? What's in the square brackets here and what's in the numerator here? Are they the same? And therefore it should result in the same result. Yeah? Okay? I think honestly, like, this is the easier go, I think, and it works all the time. But again, it's your comfort level with the GCF and working with the negative exponents. But here's the fun part. I'm going to show you a way of doing this without any negative exponents. Okay? That probably a lot of you will like. Okay? So, the alternate strategy is something called the quotient rule. And the quotient rule, it is, okay, you just got to accept it. It's going to look weird, but you just got to accept it. So, if q at x equals f at x over g at x, where f at x and g at x are differentiable functions, where g at x is not equal 0, that's an added condition just based on the fact that you can't have a 0 in your denominator. Okay. Now, how many of you are probably thinking, okay, well, the product rule is, you guys all want to say it with me, the derivative of a product, you go derivative of the first times the second plus the first times derivative of the second. You might be in your brains going, oh, well, maybe quotient rule is the same thing but with a minus, and you'd be half right. I know. It's not fully right. So the derivative, don't write yet because you're gonna not expect something. Okay, so wait, hold your horses. Derivative of the top times the bottom minus the top times derivative of the bottom. Huh, I wrote that kind of on the high side, eh? All over the bottom squared. Because that's just how it rolls. Okay? That is it. Okay? Derivative. So notice I'm not saying first, second. I'm going to say top, bottom. Again, this is just for, like, this is like you're in your head. You never write top out. You write numerator, denominator if you're actually writing out the rule. Derivative of the top times the bottom. Minus the top times the derivative of the bottom all over the bottom squared. We got a new lovely chant you can chant to yourself as you're going to sleep tonight. Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom square. Okay. One person away. Gretchen? Is there anyone normally next to you? No? Oh, Jack. Okay. So we're gonna so you might be going, ew, gross formula. I'm never gonna use this. But as long as you remember it correctly, the nice thing about it is that if you don't have to worry about any negative exponents, which is nice. Okay? So same function using quotient rule. Okay? So derivative of the top, 6x, times the bottom, x plus 4, minus the top, 3x squared minus 5, times derivative of bottom, derivative of x plus 4, 1, all over bottom squared. So take a look at that, guys. And again, I want you to notice something. Look what's in the square brackets right above. Look what's in the square brackets right above, and look at your numerator. Are they the same? But you didn't have to like fact GCF. You didn't have to do all that part. Like it was already done for you. No negative exponents showed up. So to get that, the only thing you have to do now is simplify the numerator to God. I know, right? Okay, so 6x squared plus 24x minus 3x squared plus 5. So 3x squared plus 24x plus 5 all over x plus 5 all squared. So ta-da. Okay, function found. Derivative found. So just a question here about the domains. Just a kind of a question to ask yourself. Sometimes a domain might change in the process of taking a derivative, like what the values are allowed in the original, are they still allowed, or is there any number that was allowed in the original that's now not allowed? In this case, what is the domain of your original function? What values of x are you allowed to put into the original? What's the domain of f? X can be anything except, good. The domain of the derivative. So when I look at this, is there any additional problems, or is it still just -4 is the issue? Still just -4. Sometimes though, you might have additional restrictions, so just be aware of that. So I think the reason I just want to do that example, because they might ask you that in a question. Okay, so you're just looking at your final answer. What are we looking for? What would cause the denominator to be 0? Are there now additional problems? Okay, in an expression, if eventually something shows up, something extra showed up in the denominator, then now there's more problems. Okay, yeah. Yeah, sorry. Yeah, we should be not equals. Thank you very much. Oh, by the way, guys, the proper form is a forward slash, not a backslash. For not equals. Okay. So far, so good? Okay. So let's just practice using quotient rule. Okay. So just differentiating. So f at x equals 4x cubed minus 7 all over 2x squared plus 3. Okay, you haven't memorized yet? Derivative of the top times the bottom minus the top times the derivative of the bottom all over bottom squared. Derivative of top. 4x cubed derivative is 12x squared, derivative of 7, 0. Times the bottom, I copy the bottom. Minus top, I copy the top. Times derivative of bottom, derivative of 2x squared plus 3. 4x, very good. All over bottom as a package squared. You don't just square it, like it's illegal. You can't just go square the pieces. Wrong. Okay? Package squared. Entire denominator squared. Okay. And please don't waste your time expanding this. You guys we like this. This is factored. We don't really want to expand this. Okay? Because there's going to be like 1% of you that's going to expand it wrong, and then I have to take marks off. So just leave it alone. Okay? But the numerator, do we agree, the numerator is not as simplified as it can be? Okay, I want everyone to, hopefully we can recognize this. Do you agree the numerator is not in factored form? Factored form is everything's in brackets multiplied. There's a big subtraction right in the middle here. So the only strategy that we could potentially go for is expand, collect, get a polynomial, and then maybe it's factorable, maybe not. Okay? So again, you'll notice something kind of happening quite a bit here where it's a lot of distributive property happening. Okay? So on the odd time, you might have to do FOIL. Okay, if you guys don't write this, but if that had been this, then the derivative would have had 12x squared minus 7, and then you have to do expanding with FOIL. Okay, but a lot of the times it's just monomials. So 12x squared times 2x squared would be 24x to the 4. 12x squared times positive 3 plus 36x squared. So I'm distributing 4x to 4x cubed, and then remembering I'm subtracting. So 4x times 4x cubed is 16x to the 4, but subtracted. And then negative 7 times 4x is negative 28x, but times a negative is positive 28x. All over bottom square. Any like terms in the numerator? 24x to the 4 minus 16x to the 4 is 8x to the 4 plus 36x squared plus 28x. So it's the test. You write this as your final answer, and I give you 3.5 out of 4. Why are you going to get 4 out of 4? Because in the numerator there, you see a few nice simplifying steps that are possible. So let's start with, what do you notice about 8, 36, and 28? 4 in common. Okay. And an x. Okay, good. Okay. Okay, gotcha. So 4x. Okay. And then what's left? So we've got 2x cubed plus 9x plus 7. Okay? If the part that's in the bracket is quadratic, you should do the quick check to confirm whether you can factor it. If it's cubic, it could potentially be factorable, but you guys get, the way you would have to check is factor theorem. And I'm not going to make you do factor theorem. Okay? I'm not saying the textbook might not throw one in there, and when you look at the back, it's like, hey, they got more factor than me, they probably use factor theorem. Okay? But, and again, guys, you know, if this was an obviously factorable something, you should try to do it. Like if it was a difference of squares, or if it's x squared plus, you know, 10x plus 12 or something. You know what I mean? If it's obvious, you should try and do it. Okay. But other than that, this would be the acceptable final answer for that question. Good? Okay? Okay. For B, f at x equals 4x plus 1 all over the square root of 1 minus x. Okay? Be prepared for something like this, guys, where there's like a radical part. I don't mean just cool. Okay? So, okay. So, do I just go to town here? Should I do anything first to get ready to do this? I should maybe rewrite the bottom as blah to the exponent what? Half. Okay, so now comes the question. We're going to practice quotient rule, but if you're like, I like my product, so you can bring it up and raise it to the negative half and go to town with product rule if you want. But let's practice using quotient rule. So notice I am not changing, I did not put a prime here yet, so I'm not taking the derivative. I am just doing a rewrite. And here I go. Derivative of the top, 4, times the bottom, 1 minus x to the half, minus the top. I copy the top as a package. Times derivative of bottom. So the bottom is blah to the half. So I treat it like chain rule, right, guys? So derivative of blah to the half is half times blah to the, don't forget this part, to the negative half. And I'm running out of space, but since I have a smartboard. Okay. So half 1 minus x to the negative half. Do you guys get, there's one piece missing that if you forget it's going to mess everything up. Derivative of inside is negative 1. The other, it's a little tricky, so they reversed it on you. But it's what's in front of the x and negative, so the derivative of the inside is negative 1. Are we done? This is what a lot of students forget. They got all, okay, I did chain rule. Whew. All over bottom square. All over. Now, I'm going to write it like this for a moment. Do you guys get that something kind of cool is going to happen when you square that? Is there going to be a rational exponent anymore? Okay, but we'll get to that in the next step. Sorry, spoiler alert. Okay. Okay, so first piece, you're going to notice a trend here, guys. The first piece, usually, there's nothing to do. Like, usually, you just copy it. So 4, 1 minus x to the half. Okay, so you got to be very careful cleaning this up over here. So I have a number here of a half, and I have a negative 1. So putting that in front together would be negative times negative, positive half times 4x plus 1 times 1 minus x to the negative half. All over. I'm still gonna leave it in brackets as 1 minus x. But what would be the new exponent, guys? 1. Trust me to leave it as a package. You'll see why in a moment. And if you might even just want to leave it as a 1 for the moment, just because you'll see something that's going to happen in a bit. Okay. So, what's a little annoying in this case? Oh, there's like fraction exponents. Boo. And even though we were trying to avoid it, we couldn't avoid the fact that we had a negative exponent show up. So, I want you to think, we did one already today. So, the goal is to take out, right, factor the GCF of your numerator. Okay? So again, think of it like this. There's usually 3 pieces to each, or 2 or 3 pieces. So this time, is there a number piece to each? We have 4.5. So I'm going to say something to you. It's going to be a bit strange, but I want you to think about it. Is there a number that you could take out of 4.5? Let's take out a half. I know you're going to think it's weird, but trust me on it. We'll come back to it. Okay, so we're going to take out a half. And the 4x plus 1 is stuck with it because there's nothing in common I can take out. But 1 minus x to the half, 1 minus x to the negative half, same base. The rule is I take that piece out with the lower exponent. What's the lower exponent? Negative half. Okay, so this is the trick. So you took out half. What's left over if you divided 4 by half? 8. Bingo. It doubled. Yes? When you take out a fraction, you have to just double or triple. Like if it was a third, you would triple. You know what I mean? Like it's divide by when you divide by half, you multiply by 2. Okay? Perfect. Now, 1 minus x to the half, you took 1 minus x to the negative a half out. So I subtract the exponents here. Hopefully you're starting to notice a trend here. What happens when you subtract half minus negative half?
1.
You get 1. No more fraction exponent in there. Woo! We like this. This should happen all the time. It should always be a 1. Okay? Now, I took out half, so I don't have to, I'm going to rewrite the plus sign. I don't have to write the half because I took it out. 4x plus 1, do I have to write? Yep, so I have to write that. But 1 minus x to the negative half, oh, that's the piece I took out. So that's what's left in the brackets. Look at what's inside the square brackets. Is that not horrible? Is it kind of okay to expand and simplify that? Looks pretty straightforward. Over in front, let's decipher what this is telling me. So I have a half times 1 minus x to the negative a half. What is that really going to look like overall? Okay. Oh yeah, I did a bad thing. Good. Yeah, 1 minus x. Good. Okay, thank you. Now, and I'll be honest with you, that's such a common mistake what I just did. You get so into this and you forget about the denominator. And then I have to write, where's the denominator? And then you lose a mark. Okay, so don't forget the denominator. So what happens here? So instead of having half up here, what's going to be the equivalent way of saying half in the numerator is really what in the denominator? We're just going to bring a 2 down, and the 2 will be in the denominator. Now let's think about 1 minus x. Look what do you notice about these 2 pieces, guys? You know what? I'm gonna do this in 2 steps. I'm gonna bring the 2 down. I'm gonna bring 1 minus x to the half down and rewrite 1 minus x to the 1. You see what's gonna happen momentarily? What do you notice about those 2 pieces? Same base. I'm gonna be able to do what to the exponents by the same base? I'm gonna be able to add the exponents. Okay. Cleaning up the numerator, I'm just distributing this 8. 8 times 1, 8. 8 times negative x, negative 8x. Distributing a positive is easy peasy. Plus 4x plus 1. And I have... Okay, so negative 8x plus 4x is negative 4x. 8 plus 1 is 9. All over. 2. Okay, impress me, guys. What's the new exponent on the 1 minus x? By same base, I'm going to add the exponents. What's another way of writing 1? Maybe you wanted, maybe at this step you do a rewrite and you say, oh, 1 is the same as what over 2? 2 over 2, so my new exponent will be beautiful. Okay, so if you write this, you're going to get full marks from me. Okay? I want to make it look super pretty, like add a little sparkle. Okay? You get that that's equivalent. It just looks a little nicer. Looks a little nicer with the negative factored out. We usually don't like a leading coefficient that's negative without it. It's nicer to write it factored out. So that's what I do. But if you wrote either of those, they're equivalent, you would get the full. Okay? Now, in the case that we just did there, what I want to just going that extra mile, what if there was, and now tell me where the original function has horizontal tangents. If I want to know where this function has horizontal tangents, you set what equal to? You set the, yeah, so you set f prime at x being 0, so you put a 0 here. Anytime you have a rational expression like this equaling 0, you only care about the numerator being 0. Is there a number that would cause the numerator to be 0? If you plugged in 9/4, so that would be the one x value where there would be a horizontal tangent of that ugly original function. Okay? So I know that one is probably one of the hardest questions, and like there's not going to be like 10 of them on your test, but maybe there could be one. Okay? That's fair, because you haven't there is practice of doing that type in the homework. And just to kind of, again, do an illustration here, because the original function on its own didn't look so horrible. I'm just going to, let me go to Decimos. So if we did, so was it again? It was 4x plus 1 over, okay, 4x plus 1. Sorry, all over square root of 1 minus x. Okay, so was that it, guys? X plus 1. Is that it? 4 plus 1 over square root of 1 minus x. So it's saying 9/4 should be, what's happening at 9/4? So 9/4, okay, I think it's, okay, it's like super high up here, that's the problem. Okay, this was a bad decision. Okay, I don't know. Bad choice. Okay. I don't know why it's not showing me. I think it's just a strange example. Where are those okay. Okay, I don't know why it didn't work about it. But basically at 9/4 there should be a horizontal tangent based on the math here. Okay? So, anyways. Any questions? Okay. So now, did I make a mistake? Did anyone notice me making a mistake? I think I'm okay. I'll double check tomorrow and I'll let you know if I made a mistake. But I think like it should be a horizontal tangent there. I'm gonna find it. I'm gonna take a picture of it. I'm gonna send it to you on Remind because I don't know what's happening. But it should be a horizontal tangent at 9/4 if I do everything correctly. Okay. Determine the equation. So here again, now that we know how to use quotient rule, now you can do it to solve problems like this. Determine the equation of the tangent to the curve y equals x squared minus 3 all over 5 minus x at x equals 2. So, do you guys get that? This is, guys, okay. So you guys get that we're now applying our knowledge of derivatives to now quotients. And you don't have to go through the rigmarole of having to do the product anymore, unless you really like that method. Okay? Now you can just go to town with quotient rule. And the nice thing about when it's one of these is you don't actually have to simplify, right? As soon as you find the derivative, you can start plugging in, right? Because you just care about finding the slope. So, derivative. So, derivative of x squared minus 3 all over 5 minus x. Derivative of the top. Derivative of x squared minus 3 is 2x. Times the bottom. I copy the bottom. Minus the top. I copy the top. Times derivative of bottom. This is, you got to be careful about these ones. Derivative of 5 minus x is, okay, all over bottom 5 minus x squared. I don't have to simplify because the question wasn't find the derivative. It was find the equation of the tangent at 2. Now that I have a derivative, what do I need to get out of this? I need the slope at 2. So I need y prime at 2. So this is where, so we've been doing this, guys. You can do a little bit in your head of substituting and multiplying. I wouldn't do too much in your head. You don't want to make a mistake. If I put 2 into that first bracket, I know the first bracket's going to be 4. I put 2 into the second bracket, I know I get 3. I put 2 in here, 2 squared 4, 4 minus 3, 1 times negative 1 over 2, 5 minus 2 is 3, 3 squared 9. So I get 12 plus 1 over 9 is the lovely slope of 13 ninths. Okay. So great, I have the slope. What else do I need? Point. Well, I only gave you the x. Plug it in. Plug it in, plug it in. Okay, so plug the 2 in. The original, because that gives you points, right? 2 squared minus 3 over 5 minus 2. Again, 4 minus 3 is 1 over 3. I get 1/3. Okay, so I have slope of tangent is 13 ninths, and the point of tangency is 2 1/3. And now you make your choice of y equals mx plus b or y minus y1 equals m times x minus x1. So y minus 1/3 equals 13 ninths x minus 2. So we've got to be careful here. So we've got y minus 1/3 equals 13 ninths x. 13 ninths times negative 2 is minus 26 ninths. So 13 ninths x minus 26 ninths. And then hopefully you've noticed the way I kind of think about this is I need to add 1/3, but I'm going to add the version of 1/3 that has a denominator of 9. What version of 1/3, what equivalent value of 1/3 is something over 9? 3 ninths. And then y equals 13 ninths x. Negative 26 ninths plus 3 ninths is negative 23 ninths. There you go. Julio? That's how that works. It's a nice 4-mark question. Find the derivative, plug in 2, find the point, find the equation. If the question said find the equation of the normal, what's the one extra step you do? Negative reciprocal of this, so you get negative 9/13, and you have to use negative 9/13, so everything else would be the same. Okay? Okay. And, okay, so this last question, I'll be honest with you, not on task because it's real life, but I just to complete our notes and just to realize the fact that these types of functions do model real life scenarios. Okay, guys? The function b at t equals 50,000 plus 60 all over 1 plus 0.4t represents the value in dollars of a new car t years after it is purchased. Determine the rate of change of the value of the car at 2 years, 5 years, and 7 years. based on your answers, how would you advise someone if they were deciding whether to buy a new car or a used car? So the idea here is to actually answer the question, I need some data. The data is find the rate of change of the car at 2 years, 5 years, and 7 years. So before I can plug in numbers, what do I need first? Derivative. So anytime you're asked, again, we're bringing it back to basics, right? What is really a derivative? It's a function that outputs instantaneous rates of change, or it's a function that outputs slopes of tangents. That's the purpose of a derivative. It gives you rates of change. So that's where the second part of this unit is going to really focus on, is the rates of change part. The fact that when you find derivatives, you're finding rates of change. So if v at t is this, v prime at t is going to be the rate of change of the value of the car per year. So I'm finding an expression that's going to be output rates of change of the value of the car per year. So let's do it. Derivative of the top. So derivative of the top. Is anything happening with this 50,000 here? Derivative of the top, the derivative of constant 0, derivative of 6t is, so that's the derivative of the top, 6. Times the bottom, I copy the bottom. Minus the top, I copy the top. Times derivative of bottom, derivative of 1 plus 0.4 is 0.4. All over bottom, 1 plus 0.4t all squared. Now, in this case, because we're going to be inputting multiple values, do you guys want to maybe do a simplify step and then use it to find the values? Or else you have to use this 3 times. It's a little annoying because the t's are in multiple spots. Whereas it's up to you. What do you guys feel? Do you guys want to just plug 2 in it and 5 in and 7 into that, or would you rather simplify? Plug in, just want to go for it? Okay. I don't care. V prime at 2. 6. So 2, it goes in here. 0.4 times 2, 0.8. So 1.8. 50,000 plus 6 times 2 is 12. So 50,012 times 0.4 all over. 0.4 times 2 is 0.8, 1.8 squared. So I'm going to get a number there. You guys, it's just a plug and chug. I'm going to press pause on the video and we'll just do the plug and chugging and then we'll come back to the question. Okay, so I'll give you 3 minutes. Let's find these 3 values. Go. Okay, so we found the 3 rates. So what does this mean logically? So you're getting, what do you know as time passes, what's happening to the rate of the value of the car? It decreases. So what do you, like if you had to, like you're not, let's just assume you're not buying it new, you have to decide when you're going to buy this car. If you had to decide you're going to buy a 2-year-old car, a 5-year-old car, or a 7-year-old car, what do you think would be your best bet? Well, if you think about it, like if you buy the 2-year-old car, you're going to be paying quite a bit of money still for it. And after 1 year, it's going to be decreasing at this rate. Whereas if you buy the 7-year-old car, you can look at this last number, and that's how much the value of the car decreases. It's going to cost you less, and it goes down by less. Right? Now, you're trading off it's an older car versus a newer car, but if you want to get value for your money, do you guys get that the more used the car, the rate at which it's depreciating, does everyone know that word? Okay, is getting, the rate at which it's depreciating is decreasing, so you should wait to buy a used car because you're going to be, it's a better investment, you're not going to be losing as much money on it. Okay? So, okay. The rate of depreciation decreases over time. So it makes sense to buy a used car after a longer number of years. And I'll just put costs less and depreciates slower. I'll move this up so you can see this. Just to give you like another, like saying it the other way around, this is how the textbook says it. So the value of the car decreases at a slower rate as the vehicle ages. This suggests that it makes less sense to purchase a new vehicle because it depreciates rapidly in the first few years. So they're kind of like going the other route to describe it, but it means the same thing. Okay, so we've officially finished this portion of the unit. And so you can expect on Wednesday a very calculation-based test. Okay, 0 graphs, 0 word problems, other than equation of tangent, equation of normal, and determine locations of horizontal tangent scenarios, and then derivative questions. That's your test.
So there's no word problems there.
There's going to be no real-life word problems. So the only word problems are going to be finding equations of tangents or equations of normals, and finding locations of horizontal tangents, or points where there's horizontal tangents. So I will, do you guys have questions? Do you guys want the next 20 minutes do you want me to put the test checklist up? Okay, I'll do that. And then if you have questions, you can come. Today I can't stay after school, but tomorrow I can. So please feel free to stay after school, as well as tomorrow's period will be a pure work period of just asking me anything. Okay, so I'm calling it Unit 2 Test Part 1. And I just want to be perfectly clear that after March break, and quite quickly after March break, like either near the end of that week or the very beginning of the next week, we will be having the Part 2 of this test, which will be word problem based. Okay, there's 2 sections of this unit that we didn't cover. And those 2 sections and any word problems that have kind of been sprinkled throughout, those are all going to be fair game on that test. Okay? So, I'm going to be really general about this. So, be able to determine derivatives of functions using any of the rules studied. So any rule we've studied is fair game. So, yep. Yeah, so there's all the rules that were associated with polynomials. So remember, constant power rule, constant coefficient, sum, difference. And then throughout the rest of the unit, we've introduced product rule, chain rule, quotient rule. So any of those rules, fair game. There will be a few cases, guys, I'll just be honest with you, that I'm going to literally tell you which rule I want you to use, because sometimes there's choices. So if you see in the square brackets, I want you to use product rule, that means I don't want you to expand and then use a polynomial, like polynomial. Okay, so there will be a couple of scenarios. You will be forced to use product rule and quotient rule once each. I'm hoping that after today you like you like the quotient rule, you might like using it. Okay. So knowledge, the knowledge section is purely just finding derivatives. Okay, there's going to be, I think I put on like 6 derivatives, and you just have to find the derivatives. Each is worth 3 or 4 marks. Okay, knowledge. Then we've got so application. So the types of application questions is determine equation of tangent or normal to a given function at a given location. Be prepared to do that 1 or 2 times. determine points of where a function has so determine points or x values where a function has horizontal tangents or is parallel perpendicular to a given line. So if you've done the homework, you've seen some of that scenario where I say, find the locations where this function is parallel to this line, y equals 3x plus 5. Oh, well, what does that mean? It means I need to figure out wherever that my derivative has a slope of 3. You set it equal to 3. You just have to do, instead of setting equal to 0, you set equal to the slope. Okay? And then, know how to take derivatives in general in order to determine a derivative value of mystery functions. So what I mean by that, do you guys remember we did an example, last class, of the one where it was like, if f prime at 5 is 3, and f at 5 is 7, and f prime at 2 is this, and I give you a whole bunch of just values. But you have no idea what the function f is or the function g is or whatever. If I give you just generic functions, you should be able to apply the rules to generic functions and then just plug and chug in to get your values. So there's no function derivatives. It's more, it's using general functions, not specific functions. Is this making sense, guys? Okay, let me do it. Let me. Let me do it. Is ringing a bell from Friday now? So if h at x equals f at x over g at x minus x squared, and f at 2 is 7, and f prime at 2 is 4, and g at 2 is -1, and g prime at 2 is 5, find h prime at 2. So does everybody understand what I mean by mystery functions? I have no idea what function f and g actually are. But I've given you a whole bunch of info about them. And I've told you h at x in terms of f and g. Can we use our derivative rules in general to come up with the derivative of h? And then if I have the derivative of h, can I then find h prime at 2? Shall we do it, just to kind of practice? So before I can find h prime at 2, I'm going to find h prime at x. That's the first thing I need to do. The first thing I see is f at x over g at x. Oh, hey, wait a second, that's what? A quotient. And you guys, if you go back through your notes, guys, you guys we started every lesson, every new rule with a general rule. There they are. They're right there, right? So there's our general rule. If f at x over g at x, there's my derivative. So that's literally what I'm going to be writing here. Okay? So derivative of the top. So what would be so the top is f at x. So what's the derivative of f at x? F prime at x times the bottom minus the top times derivative of bottom all over bottom squared. But there's this extra bit at the end, don't forget, derivative of negative x squared. Well, that's just normal. That's just a normal quadratic. What's the derivative of negative x squared? H prime at 2. So you put 2's everywhere, okay? So let x equal 2. H prime at 2 is going to be f prime at 2 times g at 2 minus f at 2 times g prime at 2 all over g at 2 all squared. And don't forget minus 2 times 2. Man, I wish I knew what all of these f primes and g primes of 2 and f's at 2 and g at 2 were. Oh, isn't that the legend I basically gave you? I gave you like all of those pieces. So just plug and chug in the pieces. So just make sure you plug in the pieces in the right spots. So first thing I need is f prime at 2. That was 4 times g at 2, which is negative 1. Minus f at 2, which is 7, times g prime at 2, which is 5, all over g at 2, negative 1 squared, minus 2 times 2, 4. Number, minus 4. Okay, so, yeah. So, it becomes just a bedmass exercise. So, negative 4 minus 35 all over 1 minus 4. Negative 39 minus 4 is negative 43. Okay. I've literally told you everything's on this test, guys.
Is there going to be a question with the dy or dx and like...
There's that question on the test. There is one Leibniz notation change. Determine, good question, thank you, Rand. Determine one derivative using Leibniz notation. So what that means is it's going to be one of those, if y equals u's and u equals x's, so I'm going to give you separate functions, if y in terms of u's and u's in terms of x's, find the derivative dy by dx, and I'll be nice and it'll be at a value. So that means you can just plug in the numbers, right, once you have your derivative. Again, look back at your notes from chain rule day 2 from Friday to kind of confirm how that works, and make sure when you're doing the homework chain rule that you practice those using that strategy. And then as you work through the review, guys, I'll be honest with you, the review lacks a little bit of like meat in it in terms of number of practice questions. I actually found like online, just like someone posted like literally like crazy derivative practice package. So I might just send you a PDF. It's up to you if you want to like look through it. Obviously, there's a lot of stuff that's not applicable to you, but the first batch of this like the basic rule practice you might want to do just to kind of get the feel for it and practice. The main meat, what I'd be doing, guys, is redoing any question we did in class, redoing those, as well as the homework obviously focuses more on those types of questions for each type, so make sure you can do any rule and apply that. Tonight your job should be to get quotient rule under your belt and then feel comfortable using that and then start practicing for the test. The last thing I'll just say is on the show what you know, you could have done that entire show what you know, and I asked you to without needing the quotient rule. But now there are a few questions where you can go back and now try the quotient rule. So anytime you saw a quotient and you did the rewrite, now go back and see if you can redo it using quotient rule. You should get the same answers. And if you took a peek at my solution I sent, you might have noticed that there were some solutions that were in light blue, and those were the quotient rule versions of the solution. So you have those. Yeah. Okay, I'm gonna turn off my video, and then as promised, I will return your test.